Let's get started with our first ASP.NET Core application. Open the Visual Studio and create a new project, and we will start with a core empty project. Select C#, all platforms and web, and then locate ASP.NET Core empty template. This is what we will do, and click on next. Here give a name for your project. Type any name. I'll type my project, and select a location where you want it to be created. You can select it anywhere at any convenient location. Go to the folder where you want your project, select that folder, and place select defaults, and the next screen will show you the framework. Whatever is available on your Visual Studio, select that, and by selecting defaults, let's quickly move to get started with our first project. Details we can see later. Close this, and you will find Solution Explorer somewhere on your Visual Studio. Connected services are empty, dependent, because we haven't done anything. This launch settings file, let's have a look at it. It lists a few ports that are being used. This is for IIS Express, the server. All are defaults. You can keep them as such. Then this sets our environment as development. We'll set staging or production later on. For HTTPS, since we'll be using HTTPS profile, two ports have been listed, one for HTTP and the other for HTTPS, as you can see. And again, the development environment. The settings file remains on your computer only, and then we have app settings file. This tells the minimum log level, and the default is information. And now let's come to the program.cs file that has been created for us. In this case, the create builder method, it creates a builder object. So we'll see that it's sort of a magic. Then we build the app, and for this root get root, this will send hello world string to the output. So let's run it, and we can see that a log window appears that shows info and hello world output for the root get root on the home page. It prints a simple message, hello world, this is what we wanted. And these are the ports that you can see that this is the port that was being used. And now we can see that this is the string that was outputted for the home page. We can add a new root, let's say name, and here we'll print some other message. You should try to run this project, because this is the first starting step that must start working on your own system. And here, for example, now I'll change it to name. It will print that message, hello name. Run it on your own computer to see that it starts working so far. And in our next tutorials, we'll go to the detailed parts. We'll close it right now. Thank you. The objective of this tutorial is to display data on a page, and let's see how. This is where we left our previous tutorial. We had these lines, and this was the project. So now this time we will be using pages. So right click and add a new folder. We'll call it pages. The name of the folder is pages. and this pages spellings, they are hard coded in the engine. You should also call your folder as pages. Anything else will not work. Right click and add a new item, and this box will open. ASP.NET Core, select an empty Razor page. The name is index.cshtml, the default page. And when you add, this is like how it will appear. You will see two files, a pair of files. This .cs file is the backing class. This contains the code for this is the code file, the program file, and this CSHTML is the markup file. It contains the HTML part. So we have a pair of files for index, and this is the index.cshtml file. Let me make spaces here. So this is the page directive. This is the directive called page directive. It is compulsory for a Razor page. It is a sort of signature. It has to be present always at the start. Next we have the @model directive. This is the path to your backing class. The backing class is connected to this file through this model directive, and this is the backing class. As you can see, the index model class. This class comes from the page model class. This is the index model class, and this is where the path is my project pages index model, and you can see my project pages index model, the fully qualified path. And this @block is a custom code space that you can write your program. We will not use in this project, in this program, today's lecture, so we'll delete it away. And this is, we'll come back. We don't need onGet today, so we'll delete it. And we will add a property called public string. This property name we have added, getSet. And we also add another property int. We'll say it counter. We are adding any two properties. So these are the two properties that we have added, and then we'll add a constructor. Inside the constructor, we will set these properties to some fixed values because we are just learning, so we'll just write hoven.in. The first and the counter property, we can set it to any number, and this is what we have at the moment. So this is the constructor, and the name and counter properties have been set here. Now this name and counter, they are the data that we will show there. This is the data that we are planning to display today. This will tell you how we can show data on our Razor page. Now index.cshtml. Here we create an h1 tag. This tag we write @model dot the property that we want to display. And here this @ is a Razor syntax which says C# starts here. So this marks the point where C# starts, and model is the backing class, the reference, the object reference to the backing class instance that works here, and name is the property that we set there. So this is how we have shown add model dot this name property. This is what will be shown in the h1 tag. Now we'll come to the program.cs file and remove these because the request is now to be handled by our Razor page. So we say app.map Razor pages. So our requests will be processed by the Razor pages, and this says requests to be handled by Razor pages. So Razor page will be processed. For example, if a request is HTTPS and home page is requested, so request will be sent through a process of index. Index is the default, and in case we say we have an about route here, then an about.cs HTML file will have to be present here. It is that file which will process the request. We also have to add service for Razor pages because all the components are optional, so we have to specifically say builder.services.add Razor pages. Some projects might not use Razor pages, so we won't add, but we are using. This order is important. This order is important. Service first, then build, and then map Razor pages. So this is done first, and after that map Razor pages will handle the requests. Let's run it, and we can see that the string is in fact displayed as we expected on the home page. So next we can, this is what we displayed, and next we can, this is what we displayed, and next we can now use a for loop to display that counter. Int I equal to 0, I less than model dot counter. We don't need to use @ sign everywhere. It has to be used only where a new code starts, I++, and inside some tag we can say at I is equal to at I. So at is used wherever a new code starts. This is a break here, so break of HTML. So this @ sign similarly break here. This @ says that we are starting C# again. So you will get used to Razor syntax like that, and you should practice it also, and when we run it we see that the loop actually outputs the data. Understand this, try to study this. The Razor syntax is best learned slowly. So we'll close it right now. We'll close it, you should practice it. Thank you. In this tutorial we shall learn master pages and layout. So this diagram explains what I mean by master page. This part is called the header. This is some menu part, and this is some footer part. This part is common to all the pages of a website usually, as we see, and this internal part, it varies with each page. So this is variable, and this and this is one common, this is one common file that we can create. So it will make the maintenance very easy for us. So this is the whole point of master pages. As you can see, this is the head part, and this is some title, this is some link to CSS, this is the header, this is the menu, this is also some menu on the right side, and this is the variable part, the constant footer part. So this is the structure of a page, and this is usually written inside a file called underscore layout. So this file, it contains the overall structure, the constant part. So you can now see that this is what we were doing in the previous tutorial, and if we view the page source, we see that it doesn't contain that outer part. It contains only the HTML h1 tag, whatever we wrote, but the entire story is missing. So let's now see how to do that. On the pages folder, we will right click and add a new item. This item is called a razor layout. The name is underscore layout. It is usually fixed. This is what gets added for us, and we will open the Bootstrap website. But before that, this part will be removed by replaced by a Bootstrap website. So we open the Bootstrap home page. This is the Bootstrap website. We will copy the HTML from here. This is the HTML they have given, and this includes the Bootstrap CSS and all. So we'll copy this. You can see their website. I've copied it, and I will delete it and replace it by what I get from there. So this part is going to be constant for all the pages except, so I call it a div. I haven't added footer and header because I want to just show a quick master page concept. To this div, I will add a class. This is a Bootstrap class, says margin of 5. It's as per your requirement. And here I will add render body. This render body, let me correct it. This star I have to remove. This star, this render body will replace each page, the content of each page that we add to the pages folder. So it is this part where the insertion will take place. The page is inserted here. So if you have index page, about us page, that part will be inserted here. So this is the whole point of a master page. This is constant, common. So we make this change at one place. The entire website receives the same story for all the pages. And let's now right click and add a new item. Because things are not complete yet, we will have to search the list. We will search the list for razor view start. So this is a file underscore view start. The name is hard coded. Do not change this name. And it automatically, this underscore view start, it automatically adds a layout property called underscore layout. This underscore layout connects to your CSHTML file. This part is implied. So basically it means that the layout is this. So for all the pages, this layout is the closest underscore layout to your view start file. So this will now automatically fix the layout to all your pages in the pages folder. Next, side by side, let us also add our razor imports. view imports file. The name is again hard coded underscore view imports file. This is empty file that's created for you. The file is empty. We have to, this is a single place for all the namespaces etc. that your project will use. This is similar to the header files of C and C, headers of C and C++. This is one place, so you do not have to repeat that over and over at all the places. For example, in this index.cs HTML, we have this namespace. We will just add this namespace to the view imports file. At one place, we are just adding this directive at pages. So this will prevent repetition. We can simplify our things. So we'll here at the model, we do not have to qualify it like we were doing earlier. So this is the benefit. In a large project, you get a lot of benefit out of this. And so these three files, they make our code modular. They help us write a modular design, layout, view imports and view start. These three files, they help you write a better website. And let's now run it, and we see that this is in fact formatted, and we can see the source also, and you can see that now it is surrounded by the whole HTML story. It's a complete web page. So this is how master pages will work in our ASP.NET Core. Closing. Thank you. In this tutorial, we shall learn posting a form of one text box. We will keep the things very simple, and there will be no database connectivity. We will talk about that in later tutorials. So this is a form that user types something. When he submits it, then a message will be shown, you entered hoven.in whatever. So this is the objective, and if the user doesn't type anything, then if he doesn't type anything, if he keeps it empty, then a required validation error message must be shown to the user. So this is the objective, and for this we have to create a class. A special class could be of any name. It contains a property public string name. This name is connected to this input text box. So it is to this input that this name property is connected. Then this required tag and error message. This star required is what will appear as validation message. You can change it to whatever you do. So this is where this validation message, and then we have this prompt for this username is this text hint or placeholder that we see in our HTML forms. So this is how these various properties are attached as attributes. We were here in the previous tutorial, we were doing this. So now we can delete it, remove it, because we will add our own form. Similarly, we have this our index backing class. Let's clear it out so that we do our project today from a blank slate. So this is what we'll close other files. We'll not need them immediately, so we have closed them, and we have an empty .cs file. To this we will now add our public class input model. This is the class that will hold our properties. So the property is name that we will be connecting to our text box. So this name gets set. We can give it some default value here itself. So we write string.empty. We can add more properties as our form grows bigger. And we will now add attribute for required. this attribute required will set a property error message. This star required, I'll type slowly. So this star required will be the error message that will appear there. Since I'm doing live, mistakes are possible, but we'll do it as we do. So a prompt property, this will be the property that will appear as placeholder. We write it as username. Similarly, a second property that will be shown in labels. So we'll set it here, user name. Again, we have set it to the same value. Now there are some errors that are appearing which should not be there. I have made some mistake. I will no, this is not required. There is some mistake that I have done. Most probably, let me think. The name of this class should be display and not display name. So with this, our input model is complete. And this is the input model that contains all the properties that are connected to the form. So this is the input model. You can give any name you want, but usually I give it input model, and it contains a property name. And now in our index model class, this property will be used. Input model. Some people directly use name etc., but that makes it a bit complex looking. So I have put it in a separate class, and therefore I'll now use that separate class here as the property. Now I will have to decorate it with bind property attribute. Because this property is now special, it brings data. It's a two-way binding. It connects the form to your form, sends data back. So for two-way binding, we will have to add bind property, otherwise things will not work. And now we are coming to the markup, and we'll write the form. Method will be post. This is the HTML story that we always do. I'll add some bootstrap classes also. Row. So these are the bootstrap classes that help make it look good. Row calls sm auto, gap of 3. So it's only to make it look good. So this is the form, and inside this form I will add my input. So div is added, and here I will add a label, the display label. But here I will also need to connect it. So to connect it, this will have to be a special HTML tag. Special HTML tag for purposes of ASP.NET Core. This is not going to be simple HTML5 tag. So for this, we will have to add this add tag helper directive. Type it exactly like this. Star. It will actually turn your HTML5 tags into ASP.NET Core tags. This is required for form submission and some other tasks also. So remember that this has to be added, and it must be typed exactly as shown. Where comma is there, a comma is there. So this is, you can think of some magic trick that goes. Since this is to be used at various places, I will just cut it from here and bring it to my view imports common file, so that all pages will receive this. Paste it here. So this makes it modular, and I will now complete this label. ASP4, this label will be connected to the property on my backing class. So input dot name, I am typing it slowly so mistakes are definitely possible, and let me check it back. The name wait, I will have to, the name is input. This is input dot name. The input is the property here. So this input property will go, we do not use any @ here. At input is not, it is input dot name. I'll build it. Build succeeded, it means things are okay. So next I will add that input text box. ASP4 is again input dot name. We do not have to type here type is equal to text and all, because these are now ASP.NET Core tags. So this will automatically turn it into HTML tag when the processing occurs. So this is Bootstrap class, and that input is connected to the name property, and div now we'll add a submit button also. Button type is submit, and we can add your Bootstrap class to just decorate it, give it a good design. And this is the submit button that will appear at the bottom. And a span is also needed for that validation message. So text Bootstrap class text danger, and this is again connected to ASP validation for is equal to, so this will connect to the validator for the name property and will pick the correct message from the attributes we set there. So let's now, so this is the validation for, this will be red error. So this ASP validation for input dot name will do the trick for us. It will automatically pick the error, and when we run it and when we submit it, we see that the star required actually is picked correctly. So this has to be done exactly like this. You can do it on your own computer also. Follow the steps exactly. Since we do not need this label, so I'll put it visually hidden. That label will hide it for the moment so that the form looks a bit clear. So this is in a single straight line the form appears, otherwise that label was appearing and we have seen that the error message is shown correctly. Our next step is to show the feedback message. So we will write public string. This is the onPost method that I'll start. This method will be called when the form is posted. So if model state dot is not valid, if there is some problem, we will return and stop the processing, so we return page. So processing, it will print whatever errors and it will stop here. It will stop on error so that no database entries should be made after this, no processing after this, and otherwise for this I will have to show that feedback message. So I'll add that property public string message. So it is that feedback property that we will be showing. So when we come here in our onPost, we will set this feedback equal to you entered or you typed. So whatever is sent to us in the input, it's a two-way binding, so you will receive the name property field here, and this is the property, and then we will redirect back to this page so that we can show the redirect to page so that we can show the feedback. So see exactly as I have done. So this is the message that we want to show, but a redirection is taking place. So we have a question now. How will this message save itself? How will this message know after? How will it preserve till the next redirection? So this is now a question, because when a new redirect occurs, this will go to 0, go to default empty state. So how do we, so I'll show where the exact problem is. Let's type something and submit. Oh, I'm yet to add this property in the index.cshtml. So let me first add, and then I will show that it doesn't remember itself. So this is a span that will show in a color, and here I will write at model.message. This means the message should be shown here, but I'll show that it will not actually appear. Let's run it, and now I will type something, and when we submit it, nothing happens. It is because this message property, forgets it. This message property is not able to remember itself. So to make it remember, we should set an attribute called temp data. This is very often used in ASP.NET Core to preserve messages on redirects. Just add temp data, things will start working, and now you type any data, and when you click submit, now the things are working very correctly. So you should actually see the whole thing that I have done here. Do it yourself, repeat it yourself, and it's then here in our future tutorials. This can be saved to database, but we'll do it later. So this is how it completely is done. In this tutorial, we shall learn how to save data to a database, and there are various options available: SQLite, in-memory, Cosmos, Postgres, MySQL, Oracle. So many versions are available, and all these can be used in your project, and these are the NuGet packages you will need. These are common for all, and this one is specific to your database, SQLite. This one for others, like this version of MySQL, this version of MySQL, this Postgres. Whatever you use, you will change this one, and that will configure everything for you. So in this project, something is submitted and a record saved message is shown. In the next tutorial, we shall show how to display that data, but it will save only this time. So we'll be covering Entity Framework Core, migrations, and connection strings through app-settings.json file. So this is the objective of this tutorial. So let's now begin. This is what we were doing in the previous tutorial. You can go through that for a better understanding of this tutorial, and we will start with this. First of all, I have already completed the project, so I'll show the steps. The first thing you should do is to create a model class that represents your entity. This is customer ID and this is automatically incremented primary key, and this is the field customer name in that table that will be used, and this is the validation star required, etc. We have already done this in the previous tutorial. So this is how. So model must be added for each entity. For each entity, a model class must be added to your project, like customer we have done. The next thing that we have to do is we will have a look at the main data entry page. This is the backing class, and I will explain what I have added so far for this particular project. This is bind. This we will take later. I will explain it later in this tutorial, but this bind property, as we did in the previous tutorial, this temp data for feedback message, these are as such, and then this constructor injection we'll talk later in this tutorial. Then we have an on post async with a task async, because for database operations you should use async. In the last tutorial we used I action result, but this time it should be changed to a task because database entry is going to take place. As usual, validation, and the remainder part I will take later in this tutorial. So this is the data entry form that I am actually showing to you. This is the HTML, the feedback message, the form, the label for customer name, input text box for customer name, the validator for customer name, and then this is the submit button that will actually execute the on post method that we have done there. So this is the backing class. You can have a look at this. It just contains nothing. And so after this, let us come to the project context class that we have also added. This is project context. You could have named anything, but it has to inherit from DB context. So this actually represents your database communication class. This is the class that connects to your database. Basically, it's a database communicator. And here towards the top, I have added the install packages for NuGet. We will install them one by one first. All the three will be installed. Go to Package Manager console, and I will paste that, hit enter, and let the installation complete. All the three packages I will install one by one. This is for SQLite. Paste and allow it to install. And the third one for framework tools. This one also I will add, and ensure that they add successfully to your project. In fact, as I would say, this is the first thing that you should do. Do these as your first thing whenever you do a project that involves databases. Then I'll show some parts in this class. This is a constant that represents the directory that will contain our database. This is the constructor. This constructor receives I configuration. This I configuration is received through dependency injection. You can just remember how it is occurring instead of going into details. So this is the read only. This configuration is cached through constructor. So this is the underscore configuration that is cached You can just remember this if you don't want to go into details, otherwise you can study. But why are we doing this? So that's one question that you will want to know. For this, let's come to Solution Explorer, and in the app settings file, I have added a property. This property, connection strings property that I have added, this property is called connection strings, and it contains a property called SQLite con. This is basically the connection string, your connection string that you will store in your app settings.json file. You can give any names. These connection strings, SQLite con, give any names. These names will be used in your project context. This was already there, but I have added this connection strings property, as you can see. So added this. So this is the thing that we need to read. We need to read in the project context. And as you can see, this underscore configuration is used at this point to read the connection string called SQLite con. So this is the purpose of getting your underscore configuration, so that we can read that connection string here, and I will explain the other parts. This is the DB set of your customer object, and this is pluralized property that represents the collection of all the customers for entity framework purposes. And in this override of on configuring, we will say use SQLite and pass your connection string. If you use other database, you can say use MySQL or whatever database you want to use. You will get this property somewhere there. So whatever you have, you can set it like this. So this is the overall structure of your project context. So you can have a look at the file. It's a simple file, and if this is clear, then let's move further. Next we'll come to our index.cshtml.cs file again. We get this project context again through dependency injection, and we'll cache it as underscore ctx. And it is this constructor again through dependency injection. This project context, it again comes through dependency injection provided by the system. Some magic, as you can think. So it is here, this underscore ctx is cached. And if you don't understand this, then this constructor is actually underscore ctx equal to the same thing, but in a shortcut way that has been done. It is the same constructor that actually caches or stores your project context for use. And now we are ready to understand other parts of this on post async. This is asynchronous for database connectivity. This is validator, and this is underscore ctx dot add customer. So it is here insertion takes place, and customer is obtained through the bind property. This bind property brings the data of the customer fully filled from the form, and then we add it to the context, and then we have context.save changes async, a message. If error occurs, then error message. And finally, there is a redirect to the page that will show the feedback message. This is, as you can see, the whole index model class. And finally, we have to set the program.cs also. Here, this is the create builder as already, add razor pages already, but this time we have added your DB context the project context has been added to the dependency container. So this service will be available throughout your project and map razor pages, and then we have just a log message, any message, just to show you that how logging can be done. Any log I have shown here, and after this is more important part. This will give you the services and we'll create the directory for database. This directory is the same as we wrote here. So database directory of the name database will be created if it doesn't exist, and then we extract the project context here once again. This project, if database has any pending migrations, then we'll migrate it and say identity migrations applied. All this can be seen in the console window that runs aside. And if still the database cannot connect, then have you applied migration, and this message will be shown so that the user can make an initial migration of the database, create the database. So this is what I will run it and then show it to you practically how it's going to work. So you can copy paste this code in your own projects also, modify it if it is required, but usually it works. And now with all the things in place, let's run it. We see that a failure occurs because database wasn't created, and the message as we set there, this is fail, have you applied migration? Open package manager console and run this command. This command will cause the database to be created. I've copied it and I'll bring it to the package manager console, paste it and hit enter. It will take some time and will say it's done, succeeded. And what actually happens is a migrations folder is created with two automatically created files. So this you can read yourself. It contains some table logic. So it is already created for us. And now if we run this project, the window opens and database folder, and the database is now created for us. So this is how it's actually working, and we'll now show. First run empty, validator is running, so it's correct. Now put some data and submit. Record is saved. So this means things are working okay, and in our next tutorial we'll display this data. We'll close it. Thank you. In this tutorial we shall learn how to display and delete a record. This is the display that we shall do. This is a table display that we shall do. Customer, delete these links, and we'll add a button for adding a new customer, so it will take back. And this is how the table will be generated. A for each loop will run on all the collection of customers. This tr, so each is a tr. Each tr will have customer name, this, and then a link will be there. This delete text comes from here, and this root ID is the parameter. The ID will be sent as a parameter picked from customer ID, and a page handler, the name of this delete is the name of the function that will be called for deletion. This is the schematic of that function. The name is onGet is prefixed. It is prefixed because this is a get request. So onGet is prefixed and delete is the name of the function page handler, and ID is the parameter that comes from root ID. And then we will suffix async so that we know that this is an async function, async task. And first we will pick up the customer on the basis of ID. If customer exists, then we'll say remove, save changes async, and redirect back to the page so that we can show the page again. This is how the project will look like. We already have this pages folder and we have this index page. This is the index page that you are seeing is already there. We have added a link for customers so that we can take the user to the customer's page where he can delete and see the records. This page will be added. This page will have to be added like this one has been added, customers.cshtml and its backing file. This form we have already discussed in the previous tutorial. You can see it there where we showed how to add a record name, validator, and we have this submit and all. Now today we have this customers page added, and in this customers page we have the page directive that shows the route format. The handler will receive the delete function name and ID will receive the parameter. This will automatically reach your function. We'll show in a moment, and we have this link at the top for adding a new customer. But right now this is the headers, that customer and delete. This is the collection over which a for each will run. Let me show where this collection comes. Open the backing file. This is the customers model backing class. This project context for databases is received through dependency injection, the DI, and it is cached here, project context, so it will ultimately be available to all the functions. And this is the list of customers that we have shown in that for each, accessed through model.customers, and this is filled through the onGet async when the page is opened for the first time. This context customers to list async will fill the customers, and I can also simultaneously show the onGet delete async also. Find the customer, if customer exists, remove async, and this is the completed backing class. Now let's come back to our for each loop. This is the collection, and we will be generating a tr page handler and pass the ID and name of the handler. So these are going to work for us, and now we can run to see. So this index page, see all customers, the list of customers is now there. Click on delete and deletion takes place. Click on delete and deletion takes place. So this is how the whole thing works. You can obtain the source code from me. I'll close it right now. Thank you. OTP based authentication and authorization. Let us first of all understand the basic scheme that I'll implement. We have a home page, and we have a members page which only authorized users can view, and we have a login page also where user performs some login. When the user goes to the members page from the home page and he is not authorized, he's brought to the login page, and he can directly also come to the login page, or directly he can come, and on the login page we will show him enter phone, and there will be some button get OTP, and when OTP is sent to his phone number, this is phone, and after that on the same page we'll use JavaScript etc. to show enter OTP, and when he clicks and is authorized, he reaches the members page, and if he fails authorization, we will take him to access denied page. This is the basic scheme that we shall do. So let's see the whole project in Solution Explorer. I'll walk you through the main parts. You can study the project yourself. The program.cs file, this file is already open in front of us. In this file we have the usual Razor pages, project context for databases, add Razor pages, and here we add an authorization policy for the members area. This is the members area. It is inside the areas folder as usual. You can see members area pages folder, and this is some home page of the user, the protected page that he'll want to visit. And next we have set the cookie based authentication, and login page access denied path, the place where he goes on denial, and we have set it to back to the index page, the home page from where he'll see the login etc. Then expiry time span, we can set anything, any convenient. Cookie expires in 1 year or whatever, sliding expiration true. And then we have that service for authorization, that same policy that we described above. This policy says that a role of member will be required. Required role is for member when he visits the protected page. On the same page we have the usual boilerplate, and towards the end we have that database section for migrations. Here this whole logic is for migrations, and this is the migration that you will have to apply when you start the project. Copy it, and then this has to be pasted to the NuGet package manager console. Since I have already applied here, so I'll just show you where to paste and all. After that you hit enter and everything gets applied, but it's already in the source code, so you don't need to do that. Then we have this project context here. Where is this project context? It is inside the models folder, project context. These are the NuGet packages that you must apply. Project context, the database directory, then you will have to study this whole code yourself because it's all repetition. The connection string is stored inside a configuration file by the section SQLite con by the name. This is where the SQLite con connection string is stored. Double click and we can have a quick look also. The section for connection strings contains the SQLite con property, and this is the string. It is a simple connection string that I have used. This 0 is the format placeholder which will receive the name of the directory. The database directory is just the connection string that's being fetched here, and this is the database directory that will be substituted to this 0, the placeholder. In the same models folder, we have a model for customer, various properties, customer ID, last OTP, validity, is phone confirmed, anything you can add more as per your requirements. So after this, let us come back to the program.cs file. Here we have the pages folder, the home page of the website, the home page of the whole website. We have just not done anything here, it's just a placeholder, nothing else. So one link for premium stuff is there so that the user can go to the members area. Only a few I have done because this is just a demo project and all for teaching. So it's just an empty page. We are interested in the link for members page, and after this, let me first come to the access denied page. Again, two links are given, one is for retry, one is back to home. I've kept things very simple, and then we have the members area. Here we have this protected page for the members that simply shows the name of the user who has logged in. This is saying that we should have put a question mark here because it is a null warning, nothing else. And let us now come to the login page. This is the markup. You can see that we have some simple markup here, some logic, if else logic. So this is just if else logic for forms. One is for OTP, other is for phone. So this is you can see it yourself, it's nothing but some OTP form, then submit, cancel. Then we come to the backing class. Here we have a few properties for phone, OTP. These are bind, and this is temp data that we need at various places for showing messages, success or failure. If on the GET request, if user is already authenticated, he is taken directly to the members page, directly to members area, and otherwise on post will receive those inputs. This is the if else story. This will create a new customer or find a new customer and all automatically. So register if not already registered. Customer is automatically created here. So this is just if else logic as per your requirements. OTP is created. You can use random number class to create, add any validity, 3 minutes, save changes, and then send the OTP to the customer. This is done through third party APIs. Finally, if the customer is authenticated, then claim, role and are created, and sign in async happens and user is redirected to the members area, otherwise access denied area page. Let me run it. This is the home page that opens. Click for premium and other things on this page. These are whatever we wrote there, this is for your help only. Then click here for premium. User is redirected, phone number is entered, get OTP clicked, then OTP is sent, and during testing 1 2 3 4 we do. Let's enter some wrong OTP. Login failed, retry, and this time we will enter the correct OTP, and this way the user reaches the members home page. I'll close it right now. Thank you.